Hello, and thank you for tuning into this week's episode of Bite Size Cybercrime, the podcast where we discuss cybercrimes and cybersecurity news. Now, this week's story isn't the biggest hack in the world, but it did bring me down a rabbit hole that I did not know existed, and I just want to talk about it. This is about an app that the Vatican has called Click to Pray, and this is unrelated to the attack, but I learned that they also have a rosary smartwatch. It has black agate beads and a smart cross that's activated by making the sign of the cross. I completely respect whichever religion people follow, as long as you're not hurting anyone, of course. But I think famously, you don't need a smartwatch to use a rosary, which is a physical string of beads and a cross. I just thought it was interesting such a thing even exists. I guess it does integrate into the Click to Pray app. It allows you to access the prayer database. It seems like Catholics are very mixed on whether this is blasphemous or not. I'm seeing a lot of negativity towards it online. It is $130 and also out of stock, unfortunately, if you were interested. I wasn't going to buy one, but I was curious about it. It actually looks kind of cool if you Google it. This is completely unrelated to the story. I just uncovered it when I was researching and was kind of baffled. Anyways, Click to Pray, as I said earlier, is the Vatican's official prayer app. You can sign up for daily prayers and a quick stream of other papal content on your phone or your computer. It's also a website. And it's apparently quite widely used by every country on the planet, according to that website. In January of this year, a white hat hacker by the name of Bob the Hacker discovered an insecure direct objects reference, or an IDOR vulnerability in Click to Pray. An insecure direct object reference is a broken access control vulnerability. It happens when an app or a website exposes a reference to an internal ID that you're not supposed to see. It could be a database ID or a file path, and it's required that these exist on the back end to work, but you on the front end should not be able to see or manipulate it as someone who is not an administrator with access to the back end. This can allow attackers to basically manipulate parameters within the URL of the website to access unauthorized data. URLs will commonly have these fields that have some sort of reference in them. It's a little complicated because URLs can be very long and complicated, but sometimes it's something like a ref equals or ID equals. But websites that don't handle these well, you'll be able to manually go into that URL and change that reference, and it will take you to the page without checking if you're authorized. Let's say I have an account for the website and my ID is 15. If I go to the website, something like website.com, I might see in the URL it says website.com ID equals 50. I could go in and change that ID from 15 to 60, and suddenly I would be in the account of someone else, which I'm not supposed to access. That is the basics of what direct object references can do. There was also an exposed API, or application programming interface. So what an attacker can do with all this information is query that exposed API, which you're also not supposed to be able to access as just a regular person, and then you can query those object references and it will just return the account data for any user on Click to Pray back to you. It can also return the accounts of active employees of the organization that run the app, which is known as the Pope's Worldwide Prayer Network. The Pope's Worldwide Prayer Network was contacted by Dark Reading, one of my sources for today, thank you Dark Reading, but did not receive a response. La Machi, which is a communications company that designed and developed the app, also has not responded to any emails sent to them as well. So what does this mean ultimately? Well, honestly, it's not a huge deal, but you have some implications down the line. The account information on Click to Pray is really basic. You need a first name, a last name, and an email address, and a password, and you can optionally pick what country you're from. And like in my ID equals 50 example, you can use that API that is exposed to enter different user IDs, and that information is then shown. What makes this a big deal is not necessarily the data that comes from it, because it's not the most sensitive. It's not payment information or even physical addresses, just a country and a first and last name and an email. However, this is a really quick way to phish people, because you have first and last names, countries, and email addresses right there, and you know that they are presumably Catholic. You could very easily write a phishing email disguised as some other sort of Vatican app and probably get a considerable amount of people to fall for it. More than 70,000 user accounts are just out there and available. What makes this worse, however, is that it requires no technical skill to exploit. You, listening to this podcast right now, you could go exploit this if you wanted to. And yes, I mean you, a person who is not very technical. If you're listening to this and you are very technical, sorry, you can definitely exploit it though. You are capable of changing the characters in a URL address bar. Not only can you do it, and I mean you can probably write a basic script after taking a couple of programming classes that is capable of scraping all the data from all the 70,000 users on this app/website. You could probably not even take a programming class and just Google some things and have AI write you some code to figure out how to do this. I mean, the AI might not be happy, but you could probably jailbreak it too. Now that this is publicized, and it's very much still a thing that hasn't been patched out, it's pretty much guaranteed that it has been scraped by multiple people using pretty basic scripts. And at this point, all of those people can be the easy targets of mass email impersonating the Pope's Worldwide Prayer Network, or otherwise leveraging their faith of the victims in order to trick them either into giving the attacker money, or giving them some sort of account information for some other thing, or having them sign up for some fake website and taking more data that way, or malware. There's a lot of things you could do. Insecure direct object references are a surprisingly common vulnerability given how absolutely basic they are to exploit. Not all of them are going to be as easy as this, but broken access controls are generally one of the top 10 most common web vulnerabilities according to OWASP. OWASP is the Open Worldwide Application Security Project, and it publishes information regarding application and web vulnerabilities. Not only is broken access control consistently in the top, but insecure direct object references are probably the most common version of those broken access controls. And this is because we put a lot of emphasis on authentication, but sometimes we miss out on the authorization aspect, and the authorization aspect is arguably more important than the authentication piece. They're both important, but they can't really work without each other. You can check if someone's logged in, but if you're not checking if they should be allowed to see this specific resource, then them being logged in is pretty trivial, isn't it? It's not so uncommon for religious institutions to have rather poor security, especially a lot of small family-run churches. Many of the people running the websites are not experts and don't have the budget to hire an expert. What's surprising is this is the Vatican and not some small family rural church in America. This is a huge religious institution that has a lot of money behind it. And they're still making these rather basic errors. And that's part of why I found this particular story so fascinating. However, I'm also not too surprised at the same time. It's not so uncommon that large organizations and, heck, entire countries have rather poor security. This particular topic is just something I never thought I would talk about on this podcast. Thank you to Dark Reading, Tom's Hardware, The Register, and SC Media for information on this exploit. And of course, thank you for tuning into this week's episode of Bite Size Cybercrime. And until next time, stay secure.